This podcast is supported by Siemens, your partner for industrial-grade AI.
Peter Sieber, good morning. Robert, at the A airport somewhere in the world, traveling to, I think you want to share that maybe?
Yes, I'm sitting at the airport waiting for my Air France flight to Paris because it's VivaTech and GTC Paris again. Yeah.
Oh, Paris. Oh, c'est magnificent.
Oui.
Is that the first time that I haven't been following? Of course, the world is
I think
following. Is that the first time that at least that he is coming, that they are organizing this in Europe?
no, it's not the first time. And the VivaTech Festival, I don't know, maybe the third or fourth time. It's a very big conference for tech. And it's not only about AI, but a lot is about AI for sure. But it's a big tech conference in Paris. Yeah.
Okay. Well, of course, they have what's the name of Macron? I mean, what's the function of Macron? Some of us countries have their. Is he the prime minister?
President.
He's the president, right? Well, there you go. But still, we named him differently every now and then.
Exactly.
And he's a huge supporter of technology, right? He goes around the world.
This afternoon, there's the talk with Macron, Jensen, and I think one of the Mistral guys. I will take part in this discussion.
Oh, very good. Very looking forward to hear from you next time what it is that they're talking
exactly.
about.
And there's a party today by NVIDIA, and there's a lot of industry represented. ABB, Agilox, Lockheed Martin, Novo Nordisk, Ericsson, SAP, Schneider Electric, Siemens, SNCF, and Helsing. I will make a connection to Helsing to record an episode, and I report in the next podcast episode, in the next news part, what happened in Paris.
Very good. Looking forward to.
What do you have in the news part?
Well, let's look back just a couple of minutes on Tyrex. Tyrex made such a wonderful, amazing, fantastic introduction, the king of time series. If we only look at, and they are public numbers, anybody can go to our podcast YouTube site. You see over 17,000 YouTube downloads.
That's unbelievable.
And just because we're not sharing publicly the numbers where normally we send everybody, which in the end is our service provider, but that's not important. But, we send people to Spotify or to any other podcast provider, and they always come to some place where we look at the numbers but that's amazing, number one. But much more important, how did Tyrex do on Hugging Face?
Over 100,000 downloads. Impressive. That's unbelievable. It's 1 week and over 100,000 downloads. The whole team is overwhelmed by this result, and it's unbelievable. Yeah.
Isn't that amazing?
Yeah. I think time series is a crucial problem still in the industrial sector. Yes.
In industrial, and as we have said before, anywhere in the world. I mean, whenever, many of us have had maybe a doctor's appointment or whatever, you can't imagine not getting these
energy
plugs on your breast, on your toe, I believe, somewhere. And they look at is it ECG is what we call it, in retail, looking finance. I mean, the world. It's almost like when I've said before that, the most important law has been, Moore's law, of course, 50 years, determinism. But at the same time, you could say, I'm not talking about a law here in this case, but you could say, the world has been running on data, on little data that we had in the past, so to say, but has been now increasingly running on data. And the thing that we humans always want to do, we always want to know what's going to happen. We just talked about what are you going to do today? And you give us a view on, okay, that's interesting. So something's coming up. Now, we always want to know what the future is. And that's what time series help us look into, because the algorithm, in this case, the Tyrex model, can better than any other foundation model help us understand out of the data that we have what the near future is going to look like.
I think it's the language of the machines, right? So when we talk about LLMs, we talk about text and language and large language models. And when it now comes to time series, we talk about the language of the machines, because time series are crucial for the whole processes when it comes to machines, when it comes to medical devices, etc., etc.
We've discussed this before. Yeah, you mentioned this. What was it? Was it the war of the communication protocols? So like the Profibus, the Profinet, whatever, or the CAN bus and whatever, the 10 different ones around the world. I think that is still the same. I think the protocols are still there. Now, I come to that later on. I think the protocols are, what is it, what we call now? So now you and I talk English, and we could easily switch to German. That means that certain people don't understand us. But I think we need to divide between, one is the, what do we call it? The rules. I think there's special words for the language. I think the rules of how Profinet or Profibus, as one example, how one machine communicates with the other one, they exist. Maybe let's discuss that later. And I think what the data is the contents.
Exactly.
That's
exactly.
the word. So that's the sentence that I just communicated, and you understood it, and backwards and forwards. Okay, if you, dear listener, haven't been part of it, and if you are a developer, maybe, make sure you're part of this making history of time series with Tyrex.
There are already some guys, I think Robert Gomez, a friend of you, he already started to implement Tyrex and he shared some insights. I'm really looking forward what he's doing. He's a former CERN guy, I think, in Geneva, and now has his own company, and he's already implementing Tyrex in his, what is it called? WinCCOA?
Yeah, I wasn't certain I'd heard about that, but he's explaining it. I did an interview with him at the Siemens AI for Purpose. That's now 2-3 weeks back, and we're going to listen to it, I think, maybe in 1-2 weeks.
Yeah, exactly. We will listen to it.
What do you have? I expect hundreds, thousands of you listeners, developers, to come with your solutions in all kind of markets. And typically, and I'm going to close off, and typically, yes, we concentrate with our podcast on industrial. But these days, sometimes we see, guys, girls, developers, male, female, from all these areas that we just talked about in finance and medical and everything. And, feel free to listen to our Industrial AI podcast, even if you're not necessarily doing things on the shop floor.
Exactly. You want to go on?
I have more. Yeah, I have one on LM Arena. As some of you are aware, I've been following what is called LM Arena, where real users, they choose the best of two answers to your question. What I believe to be from the very beginning, maybe 2 years ago, I think, they have raised 100 million. So they started a real company now, and they're going to continue to be a community-driven platform for understanding performance. Now, I look at it every now and then. I think if you haven't, go there, LM Arena. I do want to share maybe this one time, just to give a little bit of a view where the different solutions are. And then we can have a quick chat if we want to. Is that important to you, listener? Do you swap between one and the other, between ChatGPT and you just mentioned Mistral and the other ones?
Gemini.
I just want to quickly walk through them, not in detail, but what they have. In the beginning was only one. So whatever question you were asking, right, if it was about, as we just said, medical, the weather, whatever you wanted to know, there was only one number. And under one overview, since a couple of months now, I believe, Gemini is, the big number one, we must say, and only ChatGPT is 3, 4, 5. No, and I just want to share that quickly for the moment, and then maybe we chat. If we only look at text, it's the same picture, Gemini, and then 1, 3, 4, 5, ChatGPT, so OpenAI. If we look at web development, so the development, still Gemini. And then Claude comes in.
Yeah,
Claude
exactly.
comes in later, even stronger. Number 3 again, Gemini, and then again Claude. So and OpenAI only at place 7. Then there's a fourth one, text to image. That's where still OpenAI is number 1 with GPT. They call it GPT image. I'm not sure which one that is. And then there's a couple of other ones. And then there's search. That's again Gemini. And then there's PPL. Which one is PPL?
I've never heard.
Perplexity, I think.
Perplexity,
yeah,
maybe.
That's interesting, right?
Yeah.
Okay, that's not.
Yeah, but this is I can understand that, because for search, Perplexity is very good. It's very, very good.
I guess it's a nice confirmation of if this would not have been the result, then people would have said, well, that's really weird, maybe,
Yeah.
right? So
Yeah.
maybe this is a nice confirmation. And the final one, which is the most important one for you out there, developers, which is the Copilot, what they call Copilot, quote unquote. It's not necessarily the Microsoft Copilot, but whatever is co-piloting. And that's where DeepSeek actually is number one.
That's
and
interesting.
then Claude comes, Claude number 2 and 3. And then Mistral is there as well. They call it Code Stral, I think. And GPT, again, only at number 8. So I'm not sure we want to discuss these. What is interesting is I sometimes look at these and I listen to people say, okay, we easily swap from left to right. Some of you say I stick to the one that I started with. Of course, ChatGPT is still very, very big number one.
What about Llama, Peter?
Good question. I am just looking at the number 10, and to be honest, I haven't seen in any of these charts Llama yet. I think they probably do show up between 10 and 20, but it's a good point. I think they've had we said in the beginning, what did you say? You are on an Apple device, I believe.
Exactly.
And we say, oh yeah, does that still exist?
We don't want to discuss the paper now,
We don't
people.
want to discuss Apple. It's amazing. Everybody talking about this one paper, which is about what reasoning cannot happen.
We will
I
share it
think
in the show notes. We can share this
you
paper.
will. We
Yep.
can discuss it now.
No, I have to catch my flight, Peter.
Okay, good. So I think these guys do a great job. If you haven't tried them out, look at them and at least look at also their leaderboard. That's what it is, really.
Exactly.
So if you're interested in understanding what real humans, what they think is the best in any of these areas, I think a leaderboard is LM Arena is very good. You have one too?
Yeah, I also have only one news, and it's a podcast that I would like to recommend to our German listeners.
Industrial AI.
No, it's not industrial. It's called Sicherheitshalber. That's a German word.
Okay.
And in the latest episode, they talk about AI and war. It's a sad topic, but it's becoming increasingly important. And they have an interesting discussion about low-tech versus high-tech. And they shared an interesting example. Do you remember this attack by the Ukraine forces with the drones on the jets? And they have car tires on the planes in Russia because that the drones or the AI is not capable to identify the planes, etc. And it's about low-tech versus high-tech. Very interesting episode. I will put the episode in the show notes. Autonomous warfare, etc. It's a very interesting discussion. We do not need to do that, Peter. So there's a special podcast for that. Who is interested in this topic? It's called Sicherheitshalber.
You are going to have an interview with Helsing. You just
exactly.
And yeah, sure. I mean, it's a topic we would rather not. There's other topics I got on the radio this morning that we rather not talk about, but things do happen in this world, and I think the only thing that we don't want to do is take position left, right, backwards, forwards. But I think we need to talk about technology, and I can only confirm that I don't know for what reason, but suddenly my LinkedIn stream is full of exactly this kind of technology.
Topics, exactly. And it's interesting because when you talk about defense and stuff like that, and when it then comes to AI, they do not talk about LLMs. It's the same as in the industrial sector, because we talk a lot about LLMs in the industrial sector, but the big use cases are not maybe the LLMs in the industrial sector in the moment. And that's the same in the defense sector. We talk about identification stuff, etc., etc. So interesting.
Is that more GoFi, more machine learning based deep learning stuff like
that? Yeah, I think so. Yeah, it's not Gen AI stuff.
I do a presentation this afternoon, and I say that don't invest in GoFi. Maybe I should correct my presentation before I deliver.
You shared a very interesting article this morning about CFD, I think, and Gen AI, right? This was very impressive.
Yeah, I'm going to talk about that. Let me switch or just go to that one first. Yeah, because, it's really about AI getting serious, and that's part of that one. Now, it all started with Dario Amodei, he is the Anthropic CEO, right? And he suggested a couple of days ago that AI could make around 50% of all entry-level office jobs obsolete by 2030. At the same time, Sam Altman, he says something very similar. He says, yes, today it's like junior employees, right, performing simple tasks, and they need to be reviewed, corrected by more experienced people. You know? And he says also, in the near future, that's going to help. That's what I do not want to concentrate on. I want to concentrate on the entry-level worker. So there's a guy called Kevin Roose. He wrote this article in the New York Times. Other people have written similar articles, I believe, and it's about the recent graduates AI job apocalypse, companies replacing entry-level workers with artificial intelligence. So there's employers saying, these tools are so good. Why do I need marketing analysts? Why do I need finance analysts? Why do I need any of these people? And I'm just putting it out there as it is, realizing that you, who I am now talking about, are listening. And nevertheless, it's important that we discuss it, I do believe. So firms are encouraging managers to become AI first. Before I approve this new job, you show me that, AI cannot do it. So it's all these developments. There's this title, L5 software engineer, which I believe is a mid-level title for programmers with 3, 5, 7 years experience. Anything below that, AI is doing it. And I know it's the same thing 2 years ago when we started talking about it, and you get like a big shitload of whatever over you. It's going to be the same now. But I think it's so important that we discuss it, because I want to know. And one of the other one was exactly the one that you just referred to, Robert, is a paper. There's 3, I think they're PhDs from the universities of Exeter and Stuttgart. And that's about a multi-agent framework for, in this case, computational fluid dynamics. And it enables fully automated end-to-end simulation from natural language query. So what does that mean? Is it still the engineer who's going to be doing this? And does he or she then need the same training? So on the other hand, is AI only going to take jobs? Or is it going to produce new ones? That's always been the case, right? We're now at what revolution are we? The fourth one, evolution, revolution. So it has always been the same. So does that mean, I saw some other article, people were suggesting we're going to have AI policymakers. Yeah, sure. That sounds very European. I don't mean that negative. And in the end, I'm going to say, I was thinking this morning when I was doing my fitness, actually. So yes, I'm not such a big friend of the regulation. And we see actually in Europe regulation turning down from, as we have, right, AI Act. But maybe it's going to come up very soon again, of the reasons that I come to in a moment. Thermal plumbers, sustainability in data centers, AI agent conductors, AI systems engineers, data engineers. Some of them we have already. So the question is, what does all of this mean to you, Robert, to you, dear listener? If you are a decision maker, you are an executive, or if you, listening, you are a student and you sit there in your classes and you listen to this, what does it mean to you? Because you're going to have another year, 2 or 3. And already now, young people coming from universities have a problem getting a job in the market, which a year ago, they were certain, I'm going to study data science, I'm going to study industrial AI. What does that mean? And what does it mean for our society? Who's going to pay for the budget that societies need? If we want to do something together as a society, we need some money, typically called taxes. So are we going to have a token tax? I think that was suggested somewhere.
Wow.
So what does it mean? Are we going to, I would like to invite you, listener, let us know. And maybe we should be talking about that in some interview. I don't know which way, but I think it's a topic that we cannot close our eyes to.
We need to talk about that. Yeah, right. Absolutely. What else do you have, Peter? Or let's switch to the main part.
I have a final one before you get on the plane. AWS Strands. So it's Colin Masson, ARC. I had an interview with him months ago, and he found this one, Strands, it's called. It's an open source AI agent SDK, software development kit. And he gives this industrial AI protocol stack big picture, where still number one, I guess it's the bottom right, OpenCUA, he says continues to play a role providing secure semantic data access from operational technology, OT. So if you want to know more, Robert and I, we do the OpenCUA podcast as well. So you can learn all about that in that podcast. On top of that would sit, according to Colin, the MCP. We talked about that. If you want to know more, go back to Colin about a month ago. That is the model context protocol from Anthropic that allows the agents to understand, interact with this data and other tools in a standardized way. Now, on top of that would then sit this one, and I'm sure there's many other ones, but this one as an example, AWS Strands. So that is this SDK for building the agents. And on top of that, then goes A2A. That's the agent-to-agent protocol from Google, right? So that enables then the multi-agent. I just wanted to share Colin's view there. I have been, in the beginning, I suggested we have these communication protocols, and what is going to be the continuous role, or if not? And are there going to be other protocols, and are they going to understand what it is needed, such that, coming back to Stuttgart Exeter, a human being, a domain expert, talking and say, make this computational fluid dynamics. I think it's a motorcycle example for me. Just do it. That's the thing. And do I need to understand any of these layers of protocol that are below it? Maybe. I'm sure at some point in time, I do not need to, I think.
Exactly. Let's switch to the main part, Peter.
You did an interview.
I did an interview with 3 guests from MAN, and the Technical University of Munich. And we talk about TruckScenes, the world's first freely available sensor and driving data for autonomous trucks. Very interesting episode about a data set and how to develop a data set. And very interesting episode, a totally new perspective. And I think we never had an episode about the data set itself. So I learned a lot. Yeah.
For autonomous driving.
Yeah, for autonomous trucks. Exactly. Trucks, it's important because trucks is different to cars. Yeah.
We haven't talked about autonomous driving for a long time.
Exactly.
We did that, 3-4 years ago. That was about the normal cars, so to say. Yeah, you bring me back yesterday. I came back from mobile working, let's call it that, from a country south of where I live, and you don't believe it. We had an official holiday, right, I believe in Austria and Germany. There must have been 100 kilometers
of traffic jam. Okay.
Cars.
Okay, great.
Standing still. But there you go, autonomous. And then I was thinking of you. I really was thinking of you, Robert, because you've been saying whenever we did about logistics, let's make sure, we need to make sure that these cars don't drive until there's going to be a slot for them. It's not, you're on the airport, your plane is not going to take off if it doesn't receive a slot between wherever you are and Paris, right?
Exactly.
And I think we're going to need something like that. And I did see many MAN trucks. I saw many, many, many other trucks as well. Yeah, I mean, you can imagine, I must have seen 100,000 trucks passing by, because then that's the way it works here in Europe. In this case, in Austria, in Italy, actually. And yeah, that was amazing. So we need to solve this. And there's going to be a tunnel also for trains. That's a completely different topic. But I'm very much looking forward to hear from them. I assume it's an open source data set for other people.
It's an open source data set. Exactly.
Very good. Looking forward
Peter,
to it.
I have to go. I have to catch the flight. I have to go to my gate. Thanks a lot.
And tell us all about it the next time. Bye-bye.
Bye-bye. Hello everybody, my name is Robert Weber and I welcome today 3 guests, Felix Fendt from the Technical University of Munich. Felix, welcome.
Welcome, Robert. Thanks for having me.
And Florian Ruch from MAN. Hello Florian, welcome.
Thank you. Welcome.
And Farisha Rizvin from MAN. Welcome, Farisha.
Hello, Robert.
It's a pleasure to have you all with us. Before we start discussing your data set approach, please introduce yourself briefly to the listeners. Please, Farisha, start.
So, hi, Robert. My name is Farija Rizvin, and I'm currently working as a perception software engineer at MAN TruckScenes in Munich, Germany.
Mm-hmm. And Florian.
Hello from my side. Florian Ruch is my name. I'm working in the same department as Farija. been with MAN already 8 years now, 10 years already if you can count my student times. And I've been a bit different positions like hardware development of sensors, sensor concepts, and now the recent years I switched a little bit to the output of the sensors and having a look at the sensor data and data pipelines.
And Felix.
Yeah, thank you. So my name is Felix Fendt. I'm a PhD student at the Technical University of Munich, and we're working together with MAN for the past 3.5 years on autonomous vehicle perception, and especially also the MAN TruckScenes dataset.
Mm-hmm. Your dataset had been accepted at Europe's last year. Can you please explain what was or still is missing in your industry, and what role does your dataset now play? Felix, please.
Yes, that's a good question. So this dataset idea basically came from the fact that currently there are many datasets out in the World Wide Web, but all of them actually focus on passenger cars. And for autonomous driving, especially for perception, it's crucial to have large-scale datasets, but so far there was no dataset available for trucking. And that's why we pitched this idea to develop a truck-focused dataset for perception development to fill in this gap. And this is MAN TruckScenes now.
What are the USPs, Florian, of your dataset?
I think just giving the key facts. So it's 747 scenes of 20 seconds each. So I think quite a decent number of scenes. And you could say that we wanted to try displaying the normal life of a truck during a day. So we have 70% of highway scenes, also some rural scenes, but of course also like in-hub driving, like in the distribution center or so, where you're collecting the trailers. So 10% of terminal driving and also some city driving, and I would say all other scenes. We also have diverse weather conditions. So we have snow, rain, sunny days, cloudy days. And also, I think what's also interesting is that we collected the data over like almost a year. So let's say summer, spring, and winter time. So I think you could say it's quite diverse.
So I'm not a truck expert, but do Mercedes or Volvo or Renault also have such data sets, Farija, or do you work together on the topics in your industry?
So currently, Robert, if you look into the data sets which are available for trucking, it's very less. I would say there are currently only 2 of them available. One of them is called Too Simple Dataset, and another one is called Sewer Mine Dataset. But the kind of data is kind of very merged. In Too Simple Dataset, it's only 2D images, and they mostly provide annotations for the lane lines only. And in other data set called a sewer mine data set, they're collected from a mining facility, and they only have got 2D bounding box annotation on camera images. So when you look into the kind of data set for multi-model concerning multiple sensors, TruckScenes is the first and the largest data set available so far related to the trucking domain. And it is also first of its kind with 4D radar data also to provide a 360-degree coverage.
What does that mean, 4D? Why is it so important?
Radar data, of course, is very less if you look into the kind of data set. And in the 4D domain, the kind of data that it records is in a 360-degree point of view. And it has got a range azimuth and elevation azimuth being recorded in a 4D radar data. So you have in our data set, we have multiple sensors. We have 4 cameras, 6 LiDARs, 6 radars, 2 IMUs, and 1 GNSS sensor. So it's sort of very much multimodal.
Okay, but why are other companies are not investing in such data sets or in such research? Or is it only closed data sets? Can you explain a bit what's happening in your industry?
I guess they should also be having data set, but could be used only for in-house development, and they're not making it open source like how we did. So this is a really different scenario when our company decided that it could benefit the research community around the world also if you're making it open source. It's also a contribution towards community development, I would say.
Yeah, exactly.
Maybe I can add a thing here. So in my experience with working with suppliers, I think many of them are really PASCAR oriented when it comes to algorithms and also the sensors. I mean, of course, you have companies focusing also on the truck market, but if it tends to apply an algorithm that is used for trucks on for cars on a truck, then they are mostly not aware of the challenges that we have. I mean, we have a huge vehicle dynamics. I think in extreme cases, you can tilt the cabin up to +8 to -8 degrees, so a 16-degree change of the tilt of the sensors. And so you need much more stable algorithms. Also, you have a trailer attached that can bend, and you have a real, that spot which can be very big if you're turning around the corner. And I think most of the people out there are not really aware of these challenges. So one of our intention was to make people aware of the challenges here, and best thing that you could do is not just talking with them, but just provide them with a set of data that they can work with.
What can they do now with this data? What is possible? You already mentioned at the end, I think in your paper, you can use it for analyzing something, your first steps to analyze the data. So what is possible now to do with this large-scale data set?
I can take up that question. So we can use this data set in order to develop the machine learning models and networks. We can use this data set to train them, evaluate them for different heads like object detection, prediction, localization, and object tracking. So all these are different aspects of a perception algorithm by how you can perceive the environment in front of you and detect the objects and decide the course of action.
Yeah. And is it possible also to have now a digital twin of the truck and train the model in a digital twin first?
So this would definitely be something that would be anticipated, but not the creation of the digital twin itself, but rather, let's say, the validation or the evaluation of it. So you have to say, so if you want to develop really a solution for trucking and for a serious application, you would need a lot more data, and you would probably also need like virtual development with artificial data. But this kind of data is tricky to validate, and TruckScenes will probably also be a good resource for all of those people to maybe develop their algorithms in simulation, but then also test it on real data provided by the TruckScenes datasets to see if this is really transferable to the real world.
Can you please explain the listeners the daily work to develop a large-scale data set like this? Because you mentioned different weather conditions. Can you explain a little bit the work behind this?
So it was not a work of a short duration of time, Robert. It took around more than a year, I guess close to 2 years, for this data set to be developed from scratch. So first of all, we needed a vehicle with sensors mounted on it. That was the first task, finding the sensors and mounting it in different positions around the vehicle. That took a lot of time. After that, we had to do a lot of drives to capture all the different conditions that we planned to be included in the data set for different weathers, different environments. So that took a lot of time. And in between, there would be a lot of problems with different sensors. Sometimes the sensors won't get recorded at the right time. So that also took a lot of time. Then after we got recorded with all the data from multiple sensors, after the drives, we need to post-process them. So we had a pipeline running of our own with the post-processing steps to convert it into the data format that we needed. And we were following the data format of the new scenes data set. So we converted the data into this format. And then we had to sit around to apply the privacy policies, the GDPR privacy policies, to get the private data, so personal data, anonymized, like the timestamps, locations, phases, and license plate. And then we had to aggregate this data together into a platform to host it. So we had to find a partner to host our data. So we requested AWS, and then we had to go behind the licensing terms of our data set, develop a development kit, where to host the development kit, licensing on that part. So I guess this was a long process for us, but a step-by-step one.
But I want to come back to process the data. How was the data annotated for each other?
We had partnership with an external company where we gave the recorded data and they gave the annotation back in 3D bounding box format. They used the LiDAR fused motion compensated points for 3D bounding box annotation. So it was a partnership with external company.
And what were the obstacles in the whole project? Can you describe maybe 2, 3 and how you solved them?
So I guess like the most challenging part of a data set, both on the data side but also on the labeling side, is to ensure the quality of it. This is the most tricky part. So how do you ensure that all sensors are correctly captured? How do you ensure that the truck, the vehicle dynamics are correctly captured? How do you ensure that everything is converted to the correct format? But then also on the labeling side, it's really important to also have a predefined labeling guidelines for those people labeling the data set. So what should be a car? What should be a truck? Up to which distance should you label the data? And so on and so forth. And then also come back and actually check all of these aspects before we release it to the public. And I guess all the quality checks, all the pipelines which need to be put in place to do this was probably the most intense and most challenging part of it.
I mean, I can add something here.
Yeah.
You mostly notice problems just when they occur. I mean, you can make up your mind, but of course you need to adapt your pipeline. You need to improve it. You need to put in checks. I think also the process, how we did it, changed a little bit starting, I would say, easily. Like we got the data and also how we process it, and then coming to more and more profound solutions to the end. So in the end, it's basically just triggering the whole thing, and you could just do some. I mean, we have pipelines where if you find there was something not really well, or we need to reprocess something because the value maybe is in the wrong units, you could just push a button and then wait for it to be ready in the end.
So you also need domain-specific knowledge for this.
Definitely, yeah. I mean, on the if you say processing side, it's basically data engineering what you need, like the knowledge of these data pipelines, these cloud systems that you're utilizing. Or I mean, that's what you should use for a project like this. It's probably not a very big scale, but you can definitely leverage the benefits from cloud systems and like general data processing approaches. But when it comes to sensors, logging systems, and the processing of the data, it's I think definitely. Or I could tell I learned a lot. I could apply a lot of my knowledge from this autonomous sensor domain. Yeah.
Perfect. So what role does synthetic data play in this whole project? Or is it only real-time data? Is it possible to merge something between your data set and to produce synthetic data? What are the next steps?
I think maybe I can also take this question. I mean, if you think of data sets for training networks, I think you could decide if you include synthetic data here or if you just go with real world data. I think at some point, if you want to reach this last 0.000 something % of solving a perception task, you need to think of methods of not only using real drive data, like these specific scenarios. And I think it's definitely valid to use simulated data of, let's say, accidents or so. You should not wait for it or create some in real life to get those data. We have I mean, this data set is basically focusing of building this foundation of training a network with truck-specific data, having truck-specific sensor positions. And I think if you're saying using synthetic data or so, you could probably use that sensor set to train synthetic data generator. But we had nothing in mind with extending the data set with synthetic data.
Felicia, you want to add something?
Yes, one of the points that I wanted to add was researchers around the world can also add on with our data set, synthetic data, to train the networks, because our data set is more focused for the long range haul trucks, for the long drives. So ODD is a lot to the highway domain, the terminal, and the logistics environment. So if you want to extend it to other domain, I think synthetic data is a good solution to generate in different kinds of environment other than the ODD that we specify to train the network.
Mm-hmm. You already mentioned, I think it was Felix, car data sets or passenger cars. Can you please, for the listeners, compare, for example, the Waymo data set with your data set? And can they be merged? Because the Waymo dataset maybe saw also trucks in their dataset, or is it not possible to merge situations?
Yes, it's a very good question, and let me come back to one of your first aspects that you mentioned. So when we presented our dataset in the NeurIPS conference, I guess the most asked question that we got was, how is this actually different from the passenger car datasets, and why do we need it? And there these truck-specific use cases come into play again. So the main differences are basically threefold. So on one hand side, we have a different ODD that we operate in. So we operate, for example, in logistic terminals and on highways where you don't see too many passenger cars, or they don't operate there for the majority of their time. Then on the sensor side, we have a USP in the case that trucks, or the sensor setup for truck is mounted much higher and it's much more diverse, because you can imagine a truck is just much larger. So you cannot just cover the entirety of the surrounding by a single top-mounted LiDAR sensor. This is just not possible. So you need multiple sensors to cover the surroundings. And last but not least, the truck-specific dynamics are very important. So a truck is not just a rigid body, but it's composed of different aspects. So you have a truck, you have a trailer, then you also have your chassis and your cabin, and all of them can move relative to one another. So this is very challenging, and this is something that you don't see in these classical passenger car datasets. But apart from that, we specifically focused on this point so that we are compatible with these passenger car datasets. As Farija already mentioned, we are using the so-called new scenes dataset format. So new scenes is also one of the very early datasets from the passenger car domain, which also defined a data format, and was also one of the very few datasets which provided all different sensor modalities, so camera, LiDAR, and radar sensors. And that's why we decided to be compatible with new scenes. So it should be easy for researchers, for other companies and people who maybe want to build up on our dataset to merge it, for example, with the new scenes dataset, to cover both domains. So to cover the passenger car domain and also the truck domain, and then have a much larger dataset on their hand to maybe build something like foundational models, which are quite prominent at the time, and something like this. So yeah, this is definitely something that we had in mind.
So some traffic foundation models.
Absolutely, yes.
Okay. When I first heard from your paper and your approach, that reminds me of BMW's Sordi. Sordi is a data set for their factory, for their shop floor. They cover the whole shop floor, a digital twin of the shop floor, etc. Is it comparable? It feels like Sordi is constantly enriching its data set. Is that also the case with you? Is there a business model developing maybe?
Maybe, yeah. Let's talk about the intentions. I think this is basically the question. So why should a company go public with its data set? What's the motivation behind it? And actually, there are 4 points which are important to consider, which we identified, which are interesting to make it actually public and not just keep it private. One of them is actually to basically boost the in-house development by driving standardization across the industry, by providing this data set and providing this data format, and to also kick off a discussion of how or what should be included, how should we record data, what format should we use, and so on. So just leading this standardization discussion. And then the second aspect.
Is there ongoing discussion in the truck business?
Yes, there is an ongoing discussion, not just in the truck business, but like in the whole, I would say, traffic domain, where they were talking about data standards, quality standards, ODD definitions, and also like the ISO is covered in this, and the ASML is covered in this. So a lot of stakeholders are involved into this discussion, yeah.
Okay, second point.
Yes, second point. So the second point is basically, this is probably the obvious one, so gaining attention. So you want to use this data set also for your marketing purposes. But what people normally forget about is you also want to attract talents as a company.
Exactly.
And this is quite important. So if you have like a data set which is known in academia, which is known by students and fellows from the same topic, then you basically have a much larger game attracting these talents for your development in-house.
But here's something, maybe MAN is not really known for developing like fancy AI applications. It's rather like you're the truck manufacturer. So I think if people now get aware of our data set, then they realize, hey, MAN is also very active in this AI community and doing research in AI. They're having cool projects. Hey, I want to work here. And I think that's also what as Felix said, that's the thing that we wanted to achieve by making this public.
If you use the dataset at your master thesis and you're now familiar with the dataset and say, oh yeah, that's a cool company, I want to work there. They are providing for helping me my master thesis or something like this. Yeah.
Exactly.
And we already have a lot of good impressions after releasing the data set. We have around 3,000 Pip downloads for our development kit. And we also are hosting competition to the public as a challenge benchmark to, if they have got a model, they can train and evaluate the model using our data set and upload the results onto our website. And we have around 1,000 Hugging Face visits. We have around 700 GitHub views, and it's quite well received by the research community so far.
So, Felix, the third point.
Yes. So the third point actually goes quite well with what Farita just said, and this is basically leveraging the open source community. And I would actually put a statement here. So I think so. I believe that no German manufacturer actually can solve the autonomous driving problem by its own. Yeah, that's just not possible. It's too complicated, and there's too much resources required actually to put the effort in. If we, for example, compare with Waymo that you also mentioned earlier, I mean, Waymo, they're spending around $1 billion US on development alone every year to develop this technology. And so far, I think no German manufacturer actually is willing to put in this amount of money to develop a solution for autonomous trucking. And that's why I strongly believe that we only can solve this autonomous driving problem together. And together is the best use case to develop together is open source, because then you not just can leverage the players from the different industry partners, but you can also leverage the power of academia, the power of open source community to faster fix bugs, to faster develop features, and to bring it earlier to the market. So this is the third big point.
But from my point of view, the industrial sector needs to learn what open source means. It's not a free lunch. It's not a free beer. So you always have to think about how can we make a business model out of open source. And that's difficult for a lot of what I would say traditional German companies to think about how can we make a business out of our open source approach.
Yes, this is a good point. I mean, there are really famous examples of really successful open source companies, something like Red Hat, for example.
Red Hat, yeah, absolutely.
But also in the autonomous driving domain, I mean, we have Tier 4, which is highly included in the Autoware Foundation, who develop an open source software stack for autonomous driving. And they also certainly have a running business model. So it is possible, but yes, you have to think a little bit differently and also place yourself in maybe a more modern way.
Yeah, absolutely. And the fourth point, Felix, you mentioned 4 points.
Yes, the fourth point is something that also is overlooked a lot by people, but it's very much tied to the third point. So as I said, you cannot solve the autonomous driving problem alone. And even if you don't want to leverage the open source community, you're certainly dependent on external partners. And it's quite hard or quite challenging actually to work together with these external partners, because there are a lot of startups, a lot of new players in the field. So you as an OEM, you first may want to evaluate how good are they or how suitable is their solution for my application. And this was quite tricky. So to share data with these external partners, to evaluate these external partners, to benchmark them is quite tricky because of GDPR, because of legal issues and everything else. But if you have a public data set, it becomes very easy, because you can just say, hey, there's a public data set, take this one and show me what you can do with it. So show me your solution on our truck data. And this makes it a lot easier to actually acquire partnerships and work together.
So it's a benchmark to acquire new suppliers.
Also, yes.
Yeah, that's the fifth point. To say, okay, you want to be a supplier, there's data sets, show me how it performs, your solution. What are the next steps when it comes to your data set? Is it now done, or are you still into research? What are the next steps, Farija?
So we are so far done with our data set, I would say. And the next steps that we are looking forward to is the development of the networks from all around the world. So we are constantly watching our Hugging Face page, where we have the evaluation of different neural networks or machine learning models that people from around the world upload. So I would say it's like a win-win situation for us and them, that they are utilizing our data set and we are also getting the best from around the world to see the results on.
Yeah, next steps. As Faricia mentioned, we actually launched our first challenge online, which is a 3D object detection challenge. But this one should be not the last challenge that we launched. So we are actually also looking into other applications, something like tracking, prediction, maybe localization or something new. So currently, or since a few years, something, for example, like occupancy prediction is quite interesting, or scene flow estimation, or maybe semantic segmentation. So there are multiple different perception applications. And for sure, we are looking into these aspects and, well, how can we maybe extend our data set by these aspects? And for sure, the detection challenge will not be the last challenge that we launched.
Last but not least, Florian, your next steps?
Maybe I have to wrap up a little bit. So we just had in the last 2 days the presentation of the final presentation of the Atlas project, where this TruckScenes dataset was funded by and was also developed in the scope.
What is it? It's a huge public-funded project, or what is it?
Exactly, yeah. I don't know exact the name of it, but it was a project mainly driven by MAN to bring autonomous driving on the highway. So for transportation, but there are also a lot of other partners included there. And so maybe the podcast is just perfect, as we just were there at this final demo the last 2 days. And I think it was quite successful, having a lot of people there being interested in that topic. And now moving forward, I would say as this project is closed, TruckScenes is also, or TruckScenes dataset is also closed. And I think there's currently no activities going on to release new datasets or improving that one. Of course, we're interested in how we could improve and maybe also extending the data set at some point if we think it makes sense. So how it is going forward, I think we just, of course, having the data set public is really nice, but we also need a little bit more data to train our networks, to improve them, to get in this into the details of solving these edge cases and so on. So I think internally we will be focusing on building highly efficient and performant pipelines, collecting a lot of new data. And I think that could maybe also be a follow-up for a new data set, but I think that's still in the stars, how this will.
So Robert, Atlas project, our TruckScenes was part of a project called Atlas, and Atlas means Automatisierte Transport zwischen Logistikzentren auf Schnellstraßen in Level 4.
Auf Schnellstraßen, okay. Okay.
Hub-to-hub operations in the German highways. That's what this project focused on. And TruckScenes was part of this project, which was funded by the Federal Ministry of Germany. Yeah.
Thanks a lot. It was a pleasure. Thank you, Felix. Thank you, Florian, Faricia. Thanks a lot for your insights, and all the best for you and your team.
Thanks a lot, Robert, for your time. It was nice talking to you as well.
Thank you, Robert.
Thank you, Robert.